Hey everybody, John Shutsky here, just setting my timer to keep myself on time. So this is the first of at least two videos. So this is number one, connected to homework number one in BSE 508 for the spring semester of 2021. So these are project selection videos. I'm going to walk through with you the various projects. Right now I have 16, so I'm going to divide them up obviously into projects 1 through 8 and then 9 through 16. There may be a late breaking project or two. So there may or may not be a set of projects or a third video that you'll want to have a look at. I'll try to keep each one of these to about a minute. Let me just say a couple things. Again, this ties back to homework number one. So make sure you pay close attention to homework number one. I'm asking you to rank projects, giving your highest ranked, the project that you have the most interest and enthusiasm about. That'll be a project you give a number 10 and then a number 9, etc. I'm asking you to only give one number 10, one number 9, one number 8, etc. And then everything after that you can spread out from a number 1 up to a number 6, obviously. So I hope that that makes sense for you. Let me just provide one other caveat when we look at these projects, these first 8. I would normally what I do is I talk about each one of these and I'll say like, oh, this would be a great project if you're general engineering in BSE or if you're natural resources in the environment. And I don't think I really am going to do that here today, largely because I think you can use your own intuition and bring your own opinions forward. So I'm not going to label these. I'm not going to put each one of these in an emphasis container, so to speak. But what I will say is this: if you are, just as an example, you're a machinery systems engineering student and you would really, really love to work on the Wetland project, which I think is project number 6 or 7. I can't remember for sure. We'll get to that in a minute. But if that's the project that you really, really would like to work on because you want to expand your interest, or maybe your thoughts have kind of shifted in the last, the last year of school, you will not be excluded. If you really, really want to do that environmental project in your machinery systems, go for it. And vice versa. If you're a food or bioprocessing or your natural resources and environment, and you see this project related to grain combines, again, go for it. Like, it's good for us to have a diversity of students on each team. And when I talk about diversity, that includes gender and ethnicity and language and all of those things that I talked about in some of the introductory material, but it also includes content diversity. So that's my preamble. Let me now jump in. I'm going to take 1 minute per project. Project number one is a project to develop a thermal or temperature monitoring system to monitor for hotspots on grain combines, grain harvesters for harvesting things like corn and soybeans. We have a big problem because these machines burn every year because you've got a lot of fuel. You've got gasoline, diesel fuel, you've got oil, but you've also got all of this crop material and you've got lots of heat sources like the engine and exhaust components. And what's really critical is that if a farmer has a fire and they want to put that fire out with a fire extinguisher, you have to be able to detect that fire. You have to detect the fire within about the first 30 to 60 seconds, because if that fire burns longer, you risk losing the combine altogether. So the idea of this is to create a monitoring system. We oftentimes monitor engine temperature by measuring the temperature of the coolant, but what I'm talking about here is monitoring the envelope around important areas like the engine compartment, and either monitoring for just the raw temperature, the actual temperature during operation, or possibly looking at the rate of temperature rise. So if the normal operating temperature in that compartment is 150 degrees Fahrenheit, and suddenly we're going 150, 180, 210, we're really ramping up quickly on the temperature, we want to make sure we give that operator time to stop the combine and actually use an extinguisher to put the fire out. Project number two. So again, pay close attention to the tabs. Project number two is to design a compost site up in Polk County, Wisconsin for organics collection. Polk County is up not too far from the Twin Cities on the Minnesota-Wisconsin border. And that we have a client up there who would like us to develop a site, to design a site. So this is going to include how we handle the compost, how we lay it out, how we protect water, water quality, and other types of environmental considerations. It includes the aeration of the compost, and it also includes some of the equipment considerations for being able to turn the compost, to get it like spread out effectively, and to be able to also manage it. So this could go a number of different directions. You can read, again, flow of truck traffic, environmental design considerations, and you can read the spreadsheet really on all of these to get more detail. The next project is a flexible robotics platform for competing in the ASABE international competition. So we have really moved full scale into the robotics competition with our main engineering association, ASABE. Typically what happens is ASABE every year will give our students across the country, I should say across the world, they'll give them a task for which you need to develop a robotic application. And that includes both the hardware platform, but also the software. So the team that works on this will in fact compete eventually in the ASABE robotics competition. This will involve, like I said, both hardware and software considerations, and also providing some leadership to that team in terms of fundraising, selecting components, and actually leading forward the efforts for our student organization. Project number 4 is a project to develop a universal attachment system for a track chair. So what's a track chair? A track chair is like a wheelchair, except that instead of having wheels, we have tracks, just like a bulldozer or another tracked vehicle or tracked implement. The idea is these track chairs are quite popular among farmers. Farmers like them because they can maneuver in uneven terrain, like around a farm or farm buildings. But it's really difficult because you can't just carry the person. Farmers may need to carry tools. They may need to have a loader or a snowplow or some type of a carrying and or lifting device. And as you can imagine, those kinds of devices that you would add on to a track chair, they change the safety implications, they change the ergonomics of a track chair, and they also change the physical dimensions, the center of gravity, and some of the other characteristics. So it will be working with a client to hopefully develop a highly universal or highly adaptable track chair attachment and or attachment system. Project number 5. Project number 5 is the wetland restoration. So every year in this class, we have students who work together with their advisor, and the advisor introduces the students to the USDA, that's the United States Department of Agriculture, and they have an agency that is located in every state and also in the national government called NRCS, the Natural Resources Conservation Service. So the students in this team will work with USDA NRCS with an actual a field or a property that has a wetland. That wetland could be like, you could look at it and say, oh, wow, that's a wetland, or it could be an area that once was a wetland that had been drained, it had somehow been destroyed. And the idea of this will be to design fully all of the parameters that will help them to restore that to its natural wetland conditions. So this obviously has applications with water, with soil, but also with plants, wildlife, and other sort of biological and environmental characteristics. Project number 6 is, you might think of it as being somewhat similar, but it involves water. It involves natural resources. It is an urban stormwater storage and treatment facility. When I say facility, we're actually talking about a physical structure. So you could think of this as a pond or other type of retention storage facility. And what's really critical is that when we work in this project with the city of Madison is obviously really concerned about stormwater runoff. And big reason for that is because we've got the lakes here in the Madison area. And what happens on urban properties with that runoff, especially on things like construction sites, roadways, big properties that have parking lots, for example, there's a lot of runoff, and we need to be able to capture that runoff before it enters the lakes. So these students will be looking at inflows and outflows, and again, the biology of that wetland or of that water storage and retention system. And then also be considering a lot of the regulations and requirements for capturing nutrients like phosphorus and other nutrients. And again, the whole idea is to protect our environment and protect our lakes. here in the Madison area. Let me just grab this picture and move it up here. This project, this is project number 7. So we've got this one and one more. Project number 7 is the design of a system on a grain combine to measure corn stalk diameter. And the idea here is that corn stalk diameter is really crucial for the adjustments on the front end, the input end of a combine as it moves through the field. You want that combine to be adjusted just correctly so that you accommodate the diameter of the corn stalk. And corn stalks can be highly variable from field to field, or even within areas of the field based on fertilizer and fertility conditions, based on the weather, and based on other characteristics, including even, for example, the type of seed and the genetics of the seed can help determine that stalk diameter. So this is about developing a sensing system and then hopefully also a controller system to not only measure corn stalk diameter, but eventually in the future to also make the adjustments for making those adjustments on the go based on the input from the measurement system. This one will be in cooperation with MacDon, which is a machinery company here in the Madison area. The final project in this video is project number 8. So project number 8 is one that is going to involve looking at data coming in from remote sensing. So the remote sensing, we're talking about things like satellites, other maybe traditional aircraft that might fly over a property, over a field, or over, a big area of land, or it could also include UAVs or drones, unmanned aerial vehicles, drones of various sizes that are now being used in agriculture. A drone is essentially, or a UAV is essentially a big data collection platform with camera and other types of spectral and visual data. And the idea is we're bringing in huge, huge volumes of data very quickly, and we want to be able to make good decisions. So the students who work on this will probably have an opportunity to work with those types of, again, more the hardware platforms, but also work with the software that will include, for example, machine learning, artificial intelligence, and somehow finding ways to use and handle and manipulate the data, working closely with the advisor. The advisor will obviously have to help this team really narrow this down into being a manageable project, which is within the scope of both BSE 508 and 509. So if you're interested in software and software applications like artificial intelligence, this would be a great project. So I'm done with projects 1 through 8. I would welcome any questions or comments that you might have. And I really would encourage you, even if you've seen a project in 1 through 8 that you're super excited about, that you go ahead and watch the projects 9 through 16. And then again, if we have any other projects that come in as late breakers here in the month of January. I'll see you soon.